Good day, ladies and gentlemen. Today we are going to be looking at trigonometry, and then in trigonometry we're going to be looking at the cast diagram. And ladies and gentlemen, my name is Kondis Maktaba. And at the end of this session, you should be able to understand the following. You must be able to find the location of a triangle in a cast diagram. And then you must be able to develop a cast diagram and know what it means. All right, ladies and gentlemen, in order to understand the cast diagram, you need to be able to appreciate the negative and positive trig functions. Trigonometric functions can be negative and they can be also positive depending on where they are. All right, now in order to appreciate this idea, let us go back to the cast diagram that we did. Now the cast diagram is something that stands like this. We've got a line like this, which is a y-axis, and then you have another line like this one, which is what? Okay, this is the y-axis, and then this one is the x-axis, and then this is the origin 0, where everything comes from. All right, so we will begin with a point. So what we simply want to do here, we want to define our trigonometric triangle, but now we want to define it in Cartesian plane. So when we define it like this, what happens is you will have a point like this. Here is this point. Now this point will have x, and then it will have y. Remember, this is where the y is, this is where the x is. And then so what you will do is you will connect this point. Sorry for my terrible connection. And then this will be r. And then when you bring this down like this is parallel to y-axis, so it's going to be y. And then this one is going to be x, because it is in the x-axis, and you will have our theta here. So now you've got a right angle triangle. When you are sitting here, you've got an opposite side, which is in this case y. You've got the adjacent side, which is x, and then you've got the hypotenuse side, which is r. Right? So when you look at this thing, let's say you try to find the sine of this angle. Now the sine of this angle is going to be opposite, which is y. So sine theta, right, is going to be what? Is going to be y over what? Over its opposite over hypotenuse, and our hypotenuse in this case is r, right? And then what about cos? You've got cos theta, which is adjacent, and our adjacent is what? Our adjacent is x, and then over r, and then you've got the last one, the last trigonometric function, which is tan theta, which is going to be equal to opposite. Remember, it's TOA, so it's going to be y over over x, right? Now, if you look at sine theta here, sine theta is positive since y is positive and r is also positive. So sine theta is what? Is positive here, right? Now, what about cos theta? Cos theta is also positive here. Why? Because x is positive and r is positive. Now, what about tan theta? Tan theta, x is positive, y is also positive. So the whole thing is positive. That means tan theta is positive. So tan theta is also positive. All right. So we say all trigonometric functions here, all of them, they are what? They are positive. None of the trigonometric function is negative here. All of them, they are positive. And then we call this quadrant between the one that is between 0 and 90 degrees. We call it what? We call it the first quadrant. So whenever you are supposed to write, whenever you are supposed to plot a sketch and then a trigonometric triangle in the first quadrant, you must always draw it like this, right? Now, let's go to now a second quadrant. Second quadrant. A second quadrant is between 0 and 90 degrees. Now, what is happening here? You just take this point again, you take it to this side now, right? So when you take this point to the side, you've got P, which is x, but now our x is what? Is it negative or positive? It is negative because x is here. And then what about our y? Our y is still here, so it's still what? It's still positive, right? And then so we draw a line from here to here, and then we bring a line down here. So if you are supposed to draw a sketch in this quadrant, you must draw it here like this. We'll explain later why do we need to do like that. Now we've got our x that is negative here. I am talking nonsense. Let us wipe this down. Okay, where is our sketch? Let us just wipe this down. It's our y. So we've got our y, which is positive here, and then our x is negative. All right. So if you look at sine theta here is opposite y over r. Here is our r. So it's y over r. It's also positive. So sine theta is positive, right? In this quadrant, the second quadrant. What about cos? Cos theta. Let's look at cos theta. Cos theta is adjacent over hypotenuse. The adjacent is minus x. Hypotenuse is r. So this is negative, this is positive. So the whole thing is negative. So cos theta is less than 0 here. Right? What about tan theta? Tan theta is what? Tan theta is TOA. So its opposite, which is y, over adjacent, which is minus x. So this is positive, this is negative. So the whole thing is negative. So it's also less than 0. All right. So it's only the sine theta that is positive in the second quadrant, and then the cos theta is negative. The tan theta is also negative. Now let's look at the third quadrant. Now the third quadrant, we draw a point again. Here is our P, and then our x is minus x. And what about our y? Our y, now this time around, is also minus y, right? And then in the same way, just pull this point to here. Excuse my drawing, and then we pull this point here, and then we'll have a 90-degree angle here. And then our y is minus y. And what about our x? Our x is minus x, is already here, and our r is always positive. Guys, note r is always positive. So what do we have here? So let's start with sine theta. Sine theta. Sine theta is what? Our theta is here. Now, okay, when we are drawing theta in the third quadrant, the theta must be here. So our sine theta is opposite over hypotenuse. So it's minus y over r. So the whole thing is what? Is negative. So sine theta is less than 0. And then what about cos theta? Cos theta. What is cos theta? Cos theta is adjacent, which is minus x, over hypotenuse, which is positive r. So minus and then positive, so the whole thing is minus. So our cos theta is also it's also negative here. What about tan theta? Our tan theta here, our tan theta is OR. So when we are here in the third quadrant, our opposite is minus y. Our adjacent is what? Is minus x. So minus minus, that is positive. So our tan theta is what? Is greater than 0. So tan theta is positive here, and then cos theta is negative, and sin theta is negative. Now the last one, we put our point again. It's P, and then our x is positive 1x. And then what about our y? Is negative y. And then again, and then we put a point here. And then here is our r. And then here is our minus y, and our theta, when you look at the fourth quadrant, it is here. So sine theta is minus y over r. So what is happening here? So sine theta is what? Is less than 0. What about cos? Cos theta. Remember, cos theta is adjacent, which is positive, over hypotenuse. So this time around, cos theta is positive here. And then what about tan theta? You will see, you will test it yourself, but basically tan theta is what? Is negative. So now, to summarize this thing, we write it like this, and then we say all trigonometric functions are positive here, and then here we say only sine is positive, and here we say only tan is positive, and then here we say only cos is positive. And how do we remember this thing? We say all station 2, Cape Town, or all student takes coffee. Ladies and gentlemen, thank you very much for tuning in. Now this is a cast diagram. Thank you very much.